Pleasant good evening to one and all. I am Parameshwari, working as Associate Professor in the Environmental Science in Tamil Nadu Agricultural University. Now it is my pleasure to stand before you to discuss a topic of utmost importance in our journey towards a environmentally conscious and the resource efficient future, that is the on-farm waste recycling technologies. As we are facing several challenges due to the growing global population, climate change, and to ensure the food security, we should explore the innovative solutions that harmonize the agriculture with the nature cycles. This on-farm based recycling technologies, it plays a crucial role for the promotion of the sustainable agriculture, and also at the same time it mitigates the environmental impacts. As the agriculture practices are continue to evolve, the need for effective waste management becomes increasingly important one. So this is about the variety of crop residues which are all available at the farm level, which includes the crop residues. After the harvest of the economic produce, there are many waste material, right? Rice straw, wheat straw, barley straw, any crop. It may be the cereal, pulse, oils, anything else. After the harvest of the economic product, so much of biomass is available that can be effectively utilized. Again, coming to the livestock waste, as in livestock also one of the integrated component in the agriculture. So here also the cattle manure, poultry waste, swine manure, animal fat, these are all available, which contains the essential plant nutrients. It can be very well recycled into the agriculture. The third component is the aquaculture. As the integrated farming system have the aquaculture also one of the component. Here also we can get the metabolic waste, fish fecus, again for the fish waste. This also contains highly proteinaceous and the nitrogen-rich material. This can be very well applied to the plants. Again for the agro-industrial waste. Here it comes again for the sugarcane bagasse, rice bran, husk, de-oiled seed cakes, because these contains the higher nitrogen when compared to the all crop residues. So these type of waste can be in the different ways effectively recycled into the agriculture. This is about the statistics about availability of the crop residues. How much is available? That means here around 317 million tons of crop residues of the among the different crops are available, which can be able to supplement about the 6.5 metric tons of all the major nutrients. So you can see that how much quantum of nutrients is available in this waste material. So this can be effectively utilized so that we can ensure the circular economy in the agriculture. This picture shows about that how much biomass, dry biomass from the different crop residues are available in our India. So among the crop residues, this rice plays a major role. That means it accounts about the 33%, followed by the wheat, sugarcane, cotton, maize, soybean, and so on. This is about the across the states, how much of biomass is available. That means compared to the other states, this Uttar Pradesh, followed by the Punjab, Maharashtra, Madhya Pradesh, these are all producing so much of crop biomass. This is about irrespective of the crops. It may be the rice, wheat, anything. So this much potential is available in our India. Can you able to guess what this picture exactly says? Anyone?
Ma'am, this is stubble burning and we are facing it mostly Punjab region, and we are also working on the same thing with biochar.
Yeah, exactly. This is about the crop residue burning. Most of the farmers thinking that this is the cheapest way to remove the crop residues. Actually, it is not that, because it is not only depleting the crop residue, plant nutrients which is available in the residues, also it is creating so much of environmental impacts, like the during the burning of the crops, it produces so much of the particulate matter. Again, it is increasing the carbon dioxide level in the atmosphere. Again, it contributes for the smog formation. What happened to the Delhi? because of the burning of these residues in the Punjab, Haryana and other places, so much of smog problem and respiratory health diseases occurred in the Delhi. Not only for the health issues, again, what happened to the soil microbiome? During the burning of the residues, it increases the soil temperature so that the soil microbiome will get affected. So the entire nutrient cycling get affected. So we should not do the burning and other things. So we can instead, we can effectively recycle this material. So this is about the, unfortunately, this picture, what it says means, this is the residue burning incidents in the South Asian countries. You can see that the pathetic condition is among the South Asian countries, India stands first for the residue burning. So we have to reduce this burning and utilize this waste in the effective manner for the agriculture. So what is the necessity? Why we should go for the farm waste recycling means it increases the soil fertility because all the essential plant, 17 plant nutrients are available in the residues also. So it can be, once it is applied to the soil, very well it increases the soil fertility. Again, it's nutrient cycling because whatever the nutrients uptake from the soil, it will be there in the crop. So once economic part is harvested, again these residues are recycling means nutrients will be recycled. Again, it increases the organic matter content because in our Indian soil, the organic carbon level is very low. So by this way of residue addition, we can increase the organic matter content. Also, it ensures the environmental protection and the circular economy because it reduces the emission of the greenhouse gases from the agriculture point of view. Again, it reduces the cost for the purchase of the chemical fertilizers, as our government of India is mostly nowadays focusing for the health point of view and also to ensure the environmental health point of view. They are focusing for the regenerative agriculture like natural farming, organic farming, conservational farming. So for that purpose, this recycling of plant nutrients in the farm itself, it is an essential one. So these are all the some of the technologies available for the recycling these crop residues. We can see one by one in detail about all these technologies. The first technology is the composting technologies. This everyone knows about that because this is a age-old techniques. Here, all the organic matter can be converted into the nutrient-rich soil amendment through the decomposition process. Here, this is the degradation process which will take place in the both the process, that means aerobic decomposition and the anaerobic decomposition. Aerobic decomposition, oxygen plays a major role. Here organic matter converted into the plant nutrient-rich amendment. Here the carbon dioxide will be released. Here carbon dioxide is the end product. In case of in the anaerobic decomposition, here energy producing process. Here in the absence of oxygen, the decomposition is taking place and it produces the fuel gas, that is the methane will be produced here. Depends on the type of raw material which we are using, we can choose for the aerobic decomposition or the anaerobic decomposition process. This picture shows about that. The methods, several methods available for the composting of the crop residues. So the Bangalore method, indoor method, NADP, Coimbatore, windrow, these are all the some of the methods available. Among the methods, this Bangalore method mostly utilizes the night soil. So here go for the anaerobic decomposition process. All other methods are mostly going for the aerobic decomposition methods. And this accelerated and the composting means here we are enriching the composting material by the addition of the nutrients. This is about the some of the steps involved for the preparation of the compost. Here, the first we need to collect the crop residues from the field. Then we need to shred it because whenever the material size is low, that means the surface area is increasing. So that the microbial activity will be higher, easily it will be degraded into the manure. So we can shred it. Then in our Tamil Nadu Agriculture University, we have the bioinoculant called TNAU biomineralizer. This is the microbial consortium which can be applied into the waste material, which will enhance the composting period. That means the composting will be finished within 45 to 60 days. So it enhances the composting. Once it is spread into the heap or the windrow, periodically we need to ensure the moisture up to 60%. Then periodically turn it. That means fortnight interval, we need to turn it to ensure the aeration. Then we need to check whether the compost is matured or not by using the physico-chemical methods. Then it can be applied into the field. Yeah. This is about some of the important factors which will influence the composting process. The first and the foremost important factor is the carbon-nitrogen ratio, because this ratio is either narrow down or the wider range means the composting process. That means the microbial activity will get arrested. So we need to have the optimum range of CN ratio 25 to 30:1 by adjusting the carbon content or the nitrogen content of the material. If we need to add the carbon content materials, we can add the residues or the coir pith. If we need to enrich with the nitrogen means, we can go for the green leaves or poultry manure or cow dung. The next important factor is the moisture. That means around 40 to 60% of the moisture has to be maintained. If you are having the commercial scale means, we can use sprinklers. Nowadays it is easy because the getting manpower is a tedious one. So if you are going for the large scale composting, another thing means we can install the sprinkler. So by fixing the time, 5 minutes or the 10 minutes of the sprinkle, it will ensure the moisture content all over the beds. Then about the aeration, being a aerobic method of the composting, 15 days once we need to turn the material. For that, if you are going for the commercial scale means, we can use this machineries. It will be easy for turning the things. Then temperature. Temperature also plays major role, because if we need to maintain the heap height of 1 meter, minimum height should be maintained as the 1 meter. Then only all the pathogens and the weed seeds present in the material will get killed. Then pH normally for the aerobic decomposition doesn't matter, but whenever this pre-digested material will be used for the vermicomposting means, we need to ensure the pH, because neutral range is needed. Because if it goes highly acidic means the earthworms may not able to survive on the waste. Again, on the particle size, here also whenever the particle size is low, that is more conducive for the microbial activity to easily degrade it. The next important technology is the compost tea. It is nothing but the liquid version of the solid compost material. So it also contains all the essential plant nutrients which can also have the beneficial microorganisms. So it can be applied as soil drenches or even the 5% of foliar spray we can do it, or along with the irrigation system through the drip fertigation, it can be applied to the field. This is about the composition of the compost tea. This compost is slightly neutral in pH and it has the high EC. It indicates that it has all the essential nutrients. So very well it can be applied in all the forms, foliar or through the soil application. This is about one study conducted with the potato with the compost tea applications. Here in the control, can see that the germination percentage, shoot length will be less when compared to the treated plants. Here the study conducted with the sweet pepper plants. Here also the compost tea application at the rate of 10% increase the yield parameters and the yield of sweet pepper plants. This compost tea not only enhances the plant growth and yield, also it is responsible for the disease suppression. The study conducted in the different crops like rice, Irish potato, French bean and eggplant potato, it revealed that it has the capacity to suppress the soil-borne disease like foot rot, common scab, stem canker, root canker, even the dollar rot in the bacterial wilt. The next important technology, recycling the farm waste, is through the vermicomposting. This is also the age-old practice. Here we are converting the organic matter into the nutrient-rich material with the help of the earthworms. This earthworms, mostly Utilus eugeniae, that is the African night crawler, is used because it has the capacity to degrade more waste material into the shorter period of time. The another technology is the vermi-wash. This is also a liquid material from the vermicompost. Here you can see that this is the first picture. This picture, this setup can be used for the production of the vermi-wash. Here any abandoned tank or any plastic containers or the earthen containers, we can use it. Here the waste material, the cow dung, earthworm, we have to place it at the top. In the bottom, we can have some pebbles or the core stand. Over that, we can have some layer of loamy soil. Periodically, we have to moisture it. Okay, through the activity of the earthworms, the vermicompost will be produced here. Then whenever we are sprinkling the water, the excess water can be collected as the vermi-wash in the bottom of the material. This vermi-wash at the concentration of the 5% can be sprayed for all the crops as a foliar spray. It contains all the essential nutrients which will be increasing the crop yield. Even with the irrigation water also, we can mix it. The next technology is the mulching. The mulching, it is one of the important component in the organic farming and the natural farming for the weed control. It is not only doing the weed control, it also enhances the soil fertility, because whenever the mulch cover is added, it is slowly decompose and increase the carbon content into the soil. Also, it reduces the evaporation loss, because nowadays the water is one of the issue for the agriculture. So it plays the three important roles. First is the suppression of weeds, then it increases the soil nutrients, and it reduces the evaporation. Besides, it increases the soil microbiome activity, because it continuously supplies organic carbon to the soil. This is about whenever we are adding the mulch into the soil, it not only adds the organic matter, also it acts as a barrier against the runoff. So it increases the more infiltration rate and reduces the rainfall impact, and the soil erosion also get reduced. This is about the study conducted with the different crops, how the mulch has increased the economic yield of different crops. The yield increased from the percentage of yield increase starting from the 9 to 47% from the different crops has been achieved by using the help of mulching. So any crop residue can be used it as a mulch. Even with the weeds also used as a mulch, provided it should not attain the age of flowering. Because once it is attained the flowering or seed setting, means again if you are using as a mulch, again it will serve, it will be as a nursery, all the weed seeds will germinate over there. The next important technology is the mushroom production. Here all the agricultural waste material can be used for the mushroom production, because for producing the paddy straw mushroom, even the button mushroom, anything, it will act as one of the substrate. So we can use it for this type of mushroom production. In the farm level itself, we can do it to increase the farm income. We can have this production technologies. The another important technology is the anaerobic digestion. Here, in the absence of oxygen, all the organic waste material can be converted into the fuel-rich biogas that produces the methane. Depends on the waste material, the biogas which may produce 40 to 60% of the methane. Also, it produces the nutrient-rich digester that is called as the fermented organic manure that contains all the plant nutrients that can be very well used for the soil amendment. Yeah, this is the process of the anaerobic digestion. The waste material can be collected, whatever the material available in the farm, that can be mixed, green waste or the dry waste, anything can be mixed. Again, we need to mix it with the water to prepare the slurry. Then it undergoes the anaerobic digestion process. Here it undergoes all the hydrolysis, acidogenesis, acetogenesis, and the methanogenesis process. then it produces the biogas, which is rich in methane. It depends on the raw material. If you are using the more of cow dung and other things, we can get even harvest up to 60% of the methane. If you are you are using the paddy straw or some crop residues alone, means the percentage may vary. Again, the gaseous material can be used for the heat production, even for the electricity generation as a fuel source, we can use it. The solid material, which is produced from the digested, that can be used for the amendment. Before using it as a amendment, it has to be stabilized or cured for the 15 to 30 days. Then it can be applied into the soil. This is the composition about the fermented organic manure. This manure has the alkaline pH and has the electrical conductivity of 2, and it has the ideal carbon-nitrogen ratio, and it contains higher potassium, phosphorus, nitrogen, all the essential plant nutrients. So this can be very well applied to the all the crops. Yes, a basal dose we can apply it, because all the manures like vermicompost, compost, this fermented organic manure, everything has to be applied in the basal, because this will release the nutrients in the slow manner, so that the entire crop growth period, the plant able to get the nutrients. This is about the one study conducted in our Tamil Nadu Agriculture University by using this biodigested slurry as a value-added supplement for the turmeric and the sugarcane. We have used up to the 12.5 tons of this fermented organic manure. This increased the yield up to the 15% in both the crops. Again, this fermented organic manure can be able to made it as a pellet, and it can be placed into the root zone also. So it is drastically increasing the vigor of that particular seedling. The next important technology is the production of the agricultural waste derived smoke water. That means the waste material can be utilized for the production of the smoke. Here, this is the setup to produce the smoke. That means here we have used the beehive. Okay, for the production of this smoke water, we have utilized the beehive. Here we can use it the vacuum pump. Okay, this is the container where we can place the residues. Once it is placed, this beehive hood can be closed. Here we can have the water in the conical flask, so that the tube can be connected to the flask. Whenever we are making the fire here, the smoke will be produced. The produced smoke will be transferred through this tube, and it here in the water it will be dissolved. Okay, this smoke contain then compounds like carcinogens, cyanohydrins, butanoids, and the hydroquinones. This will act as a biostimulant. This is mostly utilized for the seed treatment. Even for the most of the forest crops or the many agriculture crops have the dormancy. For breaking the dormancy, this smoke water can be very well utilized. As a seed treatment purpose, we can use this one. This is the pilot scale smoke water production unit. Here any drum or the earthen material, we can have it. Here this is the collection tank. Here we can use the water to collect the smoke. This is about how this smoke water have the response in the different crops in these families. It includes the Brucinaceae, Asteraceae, Ericaceae. Almost all the crop plants have responded positive way for the smoke water treatment. The next important technology is the biochar. That is the biochar. That means it is the solid material. Whatever the residues, whatever the crop residues available in the farm can be converted into the biochar through the thermochemical conversion process under the oxygen limited environment. This process is called as the pyrolysis. Here, this is the pilot scale biochar production unit. Here, this is the produced biochar. If we crush it, we can get the material soil-like material. So this can be applied into the soil as an amendment. It sequesters all the carbon. This is about the Physicochemical characteristics about the biochar. This biochar will have the alkaline in pH and it contains the higher electrical conductivity because the presence of all the plant nutrients, anion and cations, it contributes for the higher EC, and it has the higher organic carbon content up to 50%. This carbon level may vary, depends on the raw material which we are choosing. Again, it contains the higher potassium level, around 1.4% of the potassium will be there. Again, the nitrogen, phosphorus, all the secondary nutrients, everything will be there. Again, the two parameters, the zeta potential and the point of zero charge, these two parameters are important in terms of the environmental point of view for the absorption of the pollutants, not related as a soil amendment, but whenever we are using this biochar as a adsorbent for the wastewater treatment or the water filtration, these two parameters are the important. So this is the ideal level as a absorbent. It can be very well used for the wastewater treatment as well. This is about how the biochar can influence the soil properties. That means in the physical properties, even the soil structure will be maintained by the application of the biochar. Again, it improves the bulk density, porosity, even at the texture level, it plays the major role in the soil. Normally in our university, we are recommending this biochar is at the rate of 5 tons per hectare. Mostly it can be recommended in the basal level. Before the raising the crop, during the last ploughing, we are recommending to apply in the soil. Then chemical properties, it increases the cation exchange capacity of the soil, so that the nutrient uptake, nutrient release, everything will be get regulated by the addition of this biochar. Again, it increases the pH of the soil. So whenever we are having the acid soil, for that soil type, it is very well used as a amelioration purpose, it can be used. Coming to the biological properties, as it has the higher organic carbon content, so microbial activity, enzyme activity will be increased when the biochar is applied into the soil. So in the long run, it increases the soil organic matter. This is about how the biochar influences the chemical properties of the soil. Here, the study conducted by using the, can see that different quantity. Can see that different quantity of the starting from the 10, 25, 50 megagram per hectare and with the different temperature, because the biochar is produced in the thermochemical conversion process in the different temperature. The pyrolysis is the oxygen limited environment. We are converting the organic matter into the solid manure. So the temperature ranging from the 200 to 600 degrees Celsius, we can have it. Again, it depends on the what type of raw material we are choosing and what is our end use. Whether we need to increase the pH of the soil, we can go for the lower temperature. But we need to have the immobilization process or the mineralization process, we can increase this temperature. So by altering the pyrolysis temperature, we can get the variations in the biochar quality. So here the effect, it increases the pH. Again, the total nitrogen content will be increased. Again, it reduces the nitrate leaching, because nowadays the nitrate leaching is the important one parameter, because the groundwater content, most of the groundwater is having the more higher nitrate, because the nitrate level, the prescribed standard prescribed by the Central Pollution Control Board is 45 ppm. But nowadays, most of the groundwater is having more than 45 ppm. It is not because of higher utilization of the nutrients and the leaching of the nutrients from the nearby land, or the dumping of the sludges or intrusion of the sewage. Everything is contributing over there. So it leads to the, whenever we are drinking that nitrate rich water, it leads to the blue baby syndrome or the methemoglobinemia. Again, this nitrogen content is released into the aquatic system, means there it causes the eutrophication problem. So everything will be nullified by using this biochar. So again, it increases the phosphorus sorption. Whenever we use the lower temperature for the biochar production, that increases the phosphorus sorption. So this study has been conducted in the variety of soils, starting from the acidic soil, alphy soils, sandy soils, incepti soils. Almost all the soil type has been conducted. It revealed that the biochar have the positive influence on the chemical properties of the soil. This is about the biological properties, how it influences the soil fauna. If the soil fauna is increased, then it increases the enzymatic activity, and even for the mycorrhiza. Here also, through the pot culture and the field experiment, even the glasshouse experiment conducted with the different application rate of biochar in the variety of soil, starting from the acidic soil to the loamy soil and the alkaline soil, because here the pH plays a major role. So in the different soil type has been tried to assess the biological properties. So most of the soil responded in a positive way for the application of the biochar. So this is about the benefits. Here the recommendation in our Tamil Nadu Agriculture University recommends that biochar can be applied at the rate of 5 tons per hectare to harvest the benefits like the carbon sequestration, because it serves the stable form of carbon that remain in the soil for the many years. So it is one of the form of the carbon we can sequester it. Then again, it increases the soil fertility by the way of enhancing the nutrient retention and enhance the cation exchange capacity. That is the more important factor in the soil, which will plays a major role for the nutrient retention and the nutrient release, nutrient absorption by the plant. Then whenever the soil is fertile, it automatically increases the microbial and the enzymatic activity in the soil. Then water retention. So through its porous structure, as like that of the cocoa peat, it can able to retain the water. So it is helpful for the plants to alleviate the drought stress. Then the pH regulation, because as the biochar is having the higher pH, it can be very well used for reclaiming the acid soil. And then it retention for the nutrient retention, it can be used so that the leaching losses can be avoided. Then the nearby water bodies can be protected from the eutrophication and other issues. Again, for the contaminant remediation, that means this biochar has the potential to absorb and immobilize the metals and the organic pollutants from the any water or the wastewater. Nowadays, it has been utilized for the sewage treatment also as a adsorbent. So these are all the some of the benefits which can be utilized in the agriculture. So it is automatically, it increases the soil fertility and the crop productivity. The next important technology is the production of the hydrochar. This hydrochar, that means it is one of the carbon-rich material produced through the hydrothermal carbonization process. Here also the biomass undergoes high temperature and pressure in the presence of water, but without the oxygen. Okay. First thing, we have to collect the feedstock, whatever the thing available in the farm, we can collect it. Then it should be undergo the hydrothermal carbonization process. Then we can collect the hydrochar that can be utilized in the farm level as a soil amendment. You can see that this is the setup we have created to produce the hydrothermal carbonization process. Here, this is like a oven, we can use it. Here we are having a temperature control. Again, the heat switch, fan switch, everything will be there. Here we have placed the HTC reactor, that is the hydrothermal autoclave reactor. Here the biomass along with the water. Here the different ratio of solid material along with the water material, we have to mix it. Again, this liquid solid ratio depends on which purpose we are using. If we are going for acid, the hydrochar also used as a adsorbent for the pollutant removal. Again, it can also be used as a fuel supplement. Instead of the coal, this can be utilized. We have tried with the sewage sludge as a source for the hydrochar production. That is supplemented 50% of the hydrochar plus 50% of coal, produced the same higher heating value of the coal. So that can be very well substituted coal, because nowadays the coal is the non-renewable resource. We cannot able to get it as long as we need it. So this type of hydrochar can be very well utilized as a supplement for the coal. Yeah, this is about the process. Here we need to have all the material, not only the crop residues. Here also we can have it the sludge material. Once we are going for the agriculture point of view, we should not go the sludge like tannery sludge or the paper mill waste sludge or the textile sludges, because these industrial sludges may contain some toxic metals. So we can go for the either the sugarcane industries or the agro-based industries waste sludge can also be used. Sewage sludge also very well we can use it, provided that sludge doesn't contain the toxic material. If we are using the dry material, means this dry material mixed with the water. Okay, we need to optimize the temperature. Here also temperature and the pressure, solid liquid ratio. These three plays a major role, which will decide about the quality of the hydrochar. Here we have optimized temperature is the 200 degrees Celsius, reaction time of 4 hours. The solid liquid ratio is 1:9 ratio. Okay, this produces the hydrochar, which is having the higher heating value. That means it is one of the important parameters to assess the material for the fuel content. Again, it produces the processed water, because whatever the water we are using now, that will also come in the outlet. So that water usually will be acidic in nature and has the higher chemical oxygen demand. So this water also again can be used for the anaerobic digestion process to produce the methane gas. So the solid material can be used as a soil amendment for enriching the soil carbon, or for the as a adsorbent in the environmental point of view. Again, this liquid portion can be used for the production of the methane gas. So in the so many ways, this hydrochar is helpful for the environment. This is about the characteristics of the hydrochar produced. Again, this hydrochar is produced by using the paper mill sludge. So again, the raw material will decide the characteristics of the hydrochar. Normally, the hydrochar will be in the acidic in nature. In case of biochar, that is the alkaline in nature. It is a acidic in nature, so this very well can be used for reclaiming the alkaline soil. Again, the EC of this hydrochar will be very high, because it contains so much of mineral constituents, so it contributes for the higher EC. If we are going for the crop residue, means we may not able to get this much EC. Yes, we did with the paper mill sludge, so it contains the higher EC. And by having this proximate and ultimate analysis, it has all the essential plant nutrients, carbon, hydrogen, nitrogen, sulfur, oxygen, everything will be there. So it will respond in the positive way for the crop plants. This is about potentials of the hydrochar in the agriculture. Here all the waste material, any crop residue can be utilized. It has to undergo the hydrothermal carbonization process. Even we can go with the co-hydrothermal carbonization process. Here the mechanisms involved, how this hydrochar is produced, means by mixing with the water, all the waste material will undergo the hydrolysis reaction, dehydration, deamination, retention, polymerization, condensation, surface diffusion. It undergoes so many reactions, then it produces the hydrochar. Here we have characterized by using all the proximate, ultimate analysis, thermogravimetric analysis, and the surface morphology, zeta potential, everything we have assessed to assess its suitability for the soil amendment and for the adsorption of the pollutants. Once it has been mixed and it undergoes the HTC process, means it produces the hydrochar, again it produces the effluent. This hydrochar can be used as a adsorption of the water pollutants. Here also it contains the higher zeta potential and the point of zero charge. So very well it can be used as an adsorbent to remove the metals and the organic pollutants from the water stream. Then as it contains the higher carbon content, it can be utilized as a soil amendment to increase the carbon content and increase the plant nutrients in the soil. Again, as a energy carrier, it can be utilized for the supplement with the 50% of the coal plus 50% of the hydrochar can be used. It can able to produce the same higher heating value. So as a supplement for coal also, we can utilize it. Again, for the absorption of the atmospheric pollutants also, as a wet scrubber and the dry scrubber in the industry level, we can use it. Again, for the carbon sequestration, because nowadays for the climate change and the global warming, we are facing several issues. So that the atmospheric carbon dioxide level, presently we are having around 420 ppm of carbon dioxide level. We need to curtail that one. We need to reduce that one. So by the way of producing the hydrochar and other things, we can sequester the carbon content in the soil so that it will be slowly released to the in the beneficial way, not in the way of greenhouse gases. Again, the effluent that we are getting from the hydrochar that can be used for the microalgae cultivation, that will be used for the single cell protein or for the hydrogen production and other thing we can use it. Again, this water can be used for the anaerobic digestion process to produce the fuel rich methane gas. Again, this water can be, if it is needed, this water again can be recirculated into the HTC process. If it is needed, we can use it. Otherwise, this can be used for the beneficial way in other terms of like algae cultivation and other things. This is about how the hydrochar is helpful in the agriculture field. Means again, it improves the soil structure, water holding capacity, and nutrient retention, so that it really reduces the nutrient leach from the soil and it increases the slowly increases the availability to the crops. So that this is one of the option for the waste valorization. That means it reduces the environmental impact of the waste burning and the waste disposal. Again, it contributes for the storing the carbon, and also it can be used alternative to the peat for the pot mixture supplement and other things, we can use it. Then for the contaminant remediation, wherever nowadays all the water is getting contaminated, even the surface water, groundwater, river water, everywhere we are facing the trouble with the presence of the pollutants. So those pollutants can be very well removed by using this hydrochar as a adsorbent. Yeah, this is about the just a comparison between the biochar and hydrochar. These two are we are producing with the same waste material, but the process is different. Here the waste, this is a feedstock. If it is undergoes the thermochemical conversion process, it produces the biochar. If it undergoes the hydrothermal carbonization process, it produces the hydrochar. So we need to characterize it here as an abstract I have given. If we are using as a feedstock, means it can be used as a adsorbent. But if you want to use it as a soil amendment, either we need to convert into the biochar or the hydrochar. Then if we go for the carbon sequestration, another thing means feedstock cannot able to do, but biochar and hydrochar can able to do. But if we go for the fuel, means again we need to go for the hydrochar. That will act as a supplement even for the coal. Yeah, this is about one study conducted with the soluble fraction. That means in the water, the soluble fraction, that means the aqueous extract from that soluble fraction can be taken and analyzed for all the nutrient concentration. It is starting from the 20 ppm to 180 ppm of all the essential nutrients was there in that aqueous extract. This is the study conducted with the maize and tomato. How it is, this aqueous extract can be helpful for the plants to increase the vigor index. The study conducted with the maize and the tomato with the two different concentration of the aqueous extract. AQ means that is the aqueous extract, AC is the HCl extract. So both the extract responded positive way when compared to the control. So that the soluble fractions of the water portion also used as a foliar spray. This is about the dry matter production of the maize root and shoots, which is grown under the different soil, like alfisols, altisols, oxysols in the different concentration, 10 tons, 20 tons, up to in the 50 tons per hectare has been tried. So it is responded in the positive way for the increasing the dry matter production in the maize. So this hydrochar can be very well used as a soil amendment to increase the crop growth and yield for all the crops. So these are all the some of the technologies available for recycling the crop waste in the farm itself. We need not transport the material to somewhere else. Some of the pilot scale reactors I have shown that can be very well, we can design in the farm level, because transporting this huge quantum of waste material, it is not an easy matter. So we can do it in the farm level itself. Thank you.